They say the universe is infinite, but what if I told you it might actually have an edge? What's out there? Another universe? A strange barrier, or something even more mind-bending? For centuries, we've been staring into the cosmos, searching for answers. But now, scientists are piecing together evidence that could finally reveal what lies at the edge of everything we know. And trust me, the truth is stranger than anyone could have imagined. Is it the end, or is it a gateway to something even bigger? Hit that subscribe button and stay with me, because this changes everything we thought we understood about the universe. For as long as we've existed, humans have been mesmerized by the night sky. We've traced the patterns of stars, mapped galaxies, and sent telescopes and probes to the farthest reaches of space. But for every question we've answered, one has stubbornly refused to let go of our imagination. What lies at the edge of the universe? Does an edge even exist? And if it does, what's waiting for us there? Some say the universe is infinite, stretching on forever without a boundary. Others believe there's a limit, a point beyond which space itself ceases to exist. But here's the twist. What if that edge isn't what we think it is? What if it loops back on itself, like a cosmic roundabout? Or what if crossing it reveals another universe entirely? This isn't just wild speculation. Scientists are now armed with tools and knowledge that are rewriting the rulebook on how we understand space. Telescopes like James Webb can peer deeper than ever before, revealing secrets buried billions of light-years away. Theories about dark energy, extra dimensions, and even multiverses are pointing to answers that are as thrilling as they are unsettling. Think about this. The universe is expanding, but at the same time, parts of it are moving so fast they'll disappear from our view forever. Imagine if what we're observing is only the tiniest fraction of what's really out there. Beyond the faint glow of the cosmic microwave background, beyond the galaxies hurtling away from us faster than light, could there be more? What if the edge of the universe isn't an end at all, but a doorway? A doorway to places we can't even begin to comprehend. Could it be the boundary of a multiverse with infinite versions of reality? Or perhaps something even stranger, an eternal loop that connects the end of the universe back to its beginning? The answers we're uncovering might not only reshape our understanding of space and time, but challenge our very definition of existence. Stick around, because this journey to the edge of the universe promises to be one of the most mind-blowing explorations yet. The universe is full of contradictions that stretch the limits of human understanding. How can something be so incomprehensibly massive, yet governed by the tiniest quantum particles? How can it expand endlessly without crashing into anything? And does it have an edge? If it does, what's beyond that edge? Is there an end, a beginning, or something completely unimaginable waiting for us out there? Here's the real puzzle. How do you measure something that might be infinite? Can you even begin to understand a place where the laws of physics might break down entirely? Imagine standing at the shore of an endless ocean, trying to guess what lies on the other side without ever crossing it. That's the challenge scientists face when they try to study the boundaries of the universe. But let's take it one step further. If the universe has no edge, it's infinite, does that mean it just stretches on forever, repeating patterns endlessly? Or does it loop back on itself like a giant cosmic circle? Or maybe, just maybe, the universe is part of a much larger system, one that we can't even begin to comprehend. Could it be connected to parallel universes? Could there be other dimensions hidden just beyond our perception? Here's where it gets even stranger. The fastest thing in the universe, light, still has its limits. The light we see from distant galaxies has taken billions of years to reach us, but there's a limit to how far it can travel. Beyond that point, the cosmic horizon, we can't see anything. It's not that nothing exists out there, it's just that the light hasn't had enough time to reach us. So what's hiding in that unreachable darkness? Is it more of the same galaxies, stars, and planets? Or is it something completely different? Think about this. If we can't observe it, does it even exist in the way we understand? Could the edge of the observable universe be hiding something that defies our entire understanding of reality? And if the universe is expanding, what is it expanding into? Is it pushing into some kind of void? Or is it creating new space as it grows? Then there's the problem of time. The farther we look into space, the farther back in time we're seeing. When you observe a star that's a billion light years away, you're seeing it as it was a billion years ago. So, if we ever did figure out how to see beyond the observable universe, would we be looking into the future or into a completely different timeline? It's not just about what's out there, it's about how we even begin to ask the right questions. Traditional tools like telescopes only show us a slice of the picture. What if the answers lie in invisible forces, like dark energy or dark matter? These two phenomena make up most of the universe, yet we don't know what they really are or how they work. Could dark energy, which is pushing the universe apart, hold the key to what's beyond? Or could dark matter, which holds galaxies together, reveal the structure of the cosmos in ways we've never imagined? And then there's the possibility that we're thinking about this all wrong. What if the edge of the universe isn't a physical boundary at all, but a shift in dimensions? Could it be a portal to another universe, another timeline, or even another version of ourselves? The challenge of exploring the edge of the universe isn't just a scientific one. It's philosophical. It forces us to question everything we know about reality. Are we even capable of understanding the true nature of the universe, or are we like ants trying to comprehend a skyscraper? Scientists are using every tool at their disposal, massive telescopes, particle accelerators, and even advanced simulations, to piece together the puzzle. But for every answer they find, more questions arise. What's beyond the cosmic horizon? What happens to the fabric of space and time at the edges of existence? And most importantly, will we ever find out? Or are some mysteries destined to remain unsolved? The edge of the universe is the ultimate mystery. It's not just about distance, it's about the limits of human knowledge. It's a challenge that requires more than just technology. It demands imagination, creativity, and a willingness to confront the unknown. So the real question isn't just what's out there. It's, are we ready to find out? The observable universe. First, let's dive into what we can actually observe within the incomprehensibly vast expanse of space. This is where the concept of the observable universe comes in, a term that represents the slice of the cosmos that we can study and analyze, because light from those regions has had enough time to reach us. But here's where it gets fascinating. The observable universe is not a fixed boundary. It's more like a constantly evolving horizon. Right now, this horizon stretches approximately 93 billion light-years across. That's an almost impossible number to truly comprehend, so let's break it down a bit. The observable universe is tied directly to the speed of light, which is the fastest thing in the universe, clocking in at about 299,792 kilometers per second. Light from distant stars and galaxies has been traveling toward us since the moment the universe began, around 13.8 billion years ago. This is why some people assume the observable universe should be 13.8 billion light-years across, but it's actually much larger, because space itself has been expanding during that time. Think of it like stretching a rubber band while light is traveling across it. The light takes time to get to us, but in the meantime, the space it's crossing grows larger and larger. This phenomenon makes the actual observable universe vastly bigger than just the age of the universe multiplied by the speed of light. Now let's talk about why the word observable is key here. This isn't the full universe. Not by a long shot. The observable universe is just the part of the cosmos we can measure because light and other forms of radiation from that region have had enough time to reach Earth. Beyond that, it's not that the universe ends. It's simply that the light from those regions hasn't reached us yet. Why? Because the universe is so vast, and light, while incredibly fast, takes time to travel across it. Imagine standing on the shore of an endless ocean. You can see the water stretching out to the horizon, but you know the ocean doesn't stop there. It keeps going far beyond what your eyes can perceive. That's essentially what the observable universe is like. It's a horizon set by the limits of light's journey through the cosmos. Beyond this cosmic horizon, there could be other galaxies, other phenomena, or perhaps even nothing at all. And here's the kicker. This nothing doesn't necessarily mean emptiness in the way we think about it. It might be a realm of space so alien to us that our current tools and understanding can't even begin to grasp it. To add another layer of intrigue, the observable universe is deeply personal. That might sound strange, but hear me out. The observable universe is different depending on where you are in the cosmos. From Earth, we have our 93 billion light-year perspective. But imagine an observer on a planet in a galaxy 10 billion light-years away. Their observable universe would overlap with ours in some areas, but also include regions of space we can't see and exclude parts of space we can. Essentially, every point in the universe has its own observable bubble, making the concept of the whole universe even more elusive. But how do scientists even measure the observable universe? That's where things get even more fascinating. One of the primary tools is the cosmic microwave background, or CMB. This is the faint glow of radiation left over from the Big Bang, and it's the oldest light we can detect. When we look at the CMB, we're essentially looking at a snapshot of the universe as it was just 380,000 years after the Big Bang. It's like staring at a baby photo of the cosmos. The CMB is critical because it marks the farthest point from which light has traveled to us, giving us a tangible limit to our observations. But even this isn't the end. It's just the limit of what our current instruments can detect. Now let's get into the complexities of the cosmic horizon. The horizon isn't a physical boundary like a wall or a cliff. Instead, it's a limit imposed by the laws of physics. It's the farthest distance from which light can have traveled to us, given the age of the universe and the speed of light. But because the universe is expanding, regions that are currently visible will one day slip beyond this horizon. Think about that for a moment. Galaxies we can see today will eventually move so far away that their light will never reach us again. They'll fade into the darkness of the cosmos, effectively disappearing from our observable universe. It's a sobering thought that reminds us how fleeting our cosmic view really is. The expansion of the universe also introduces the concept of the co-moving distance. This is a way of measuring distances that takes into account the fact that space itself is stretching. When scientists say the observable universe is 93 billion light-years across, they're using co-moving distance. It's a bit like measuring the distance between 2 points on a rubber band after it's been stretched out, rather than its original size. This approach helps us make sense of the vast scales involved. And then there's the mind-bending idea of what might lie beyond the observable universe. One possibility is that the universe is infinite, stretching on forever with no edges or boundaries. In this case, the observable universe is just a tiny slice of an unimaginably vast cosmos. Another possibility is that the universe is finite but unbounded, much like the surface of a sphere. Imagine a 3D version of a sphere. If you travel far enough in one direction, you could theoretically end up back where you started. This would mean the universe has no edge in the traditional sense, but it still has a definable shape and size. And let's not forget the multiverse theory. Some scientists believe our universe might be just one of countless others, each existing in its own bubble within a larger multiverse. In this scenario, the edge of our observable universe might lead to another universe with entirely different laws of physics. Imagine stepping out of your house and finding yourself on an alien planet where everything operates in ways you can't even fathom. That's the level of mystery we're dealing with here. So what's the takeaway? The observable universe is a concept that's as humbling as it is awe-inspiring. It reminds us of the limitations of our knowledge, while igniting our curiosity to learn more. Every photon of light that reaches us from distant stars and galaxies carries with it a piece of the universe's history, a story of creation, expansion, and evolution. But as much as we've learned, we've barely scratched the surface. Beyond the horizon of what we can see lies a realm of infinite possibilities, waiting for us to uncover. The expanding universe? Here's where things start to boggle the mind. The universe isn't just expanding. It's doing so at an ever-accelerating pace. This isn't just a theory, it's a fact backed by decades of research and observations. But let's break it down, because the implications of this are as vast as the cosmos itself. First, imagine the universe as a giant loaf of raisin bread baking in an oven. As the dough rises, the raisins, representing galaxies, move farther apart. This is how space expands, not because the galaxies themselves are moving, but because the fabric of space itself is stretching. Now, here's the twist. In the real universe, the farther a galaxy is from us, the faster it seems to be moving away. Why? It all comes down to something called the Hubble constant, which measures how quickly galaxies recede as a function of their distance from us. When astronomer Edwin Hubble first discovered this phenomenon in the 1920s, it shocked the scientific world. Until then, most people assumed the universe was static, but Hubble's observations of distant galaxies revealed that the universe was expanding. And here's the kicker. This expansion isn't slowing down, as you might expect from gravity pulling everything back together. Instead, it's speeding up. It's like hitting the gas pedal on a car that's already racing down the highway. What's causing this cosmic acceleration? The answer lies in a mysterious force called dark energy. Dark energy is one of the most perplexing and elusive concepts in modern science. It's an invisible force that seems to be driving the expansion of the universe, pushing galaxies apart at ever-increasing speeds. And here's the mind-blowing part. Dark energy makes up about 68% of the universe's total energy content. That means most of the universe is dominated by something we barely understand. Now, let's talk about how this affects our understanding of the universe's edge. Picture this. Some galaxies are receding from us so quickly that their light will never reach us, no matter how long we wait. This isn't because those galaxies are moving through space faster than the speed of light. That's impossible. Instead, the space between us and those galaxies is expanding so rapidly that it outpaces the light traveling through it. This creates what scientists call a cosmic event horizon. Beyond this horizon, the universe becomes unreachable. Not because it's physically blocked, but because light from those regions can no longer make the journey to us. This has profound implications. It means that over time, our observable universe, the part of the cosmos we can see and study, is actually shrinking, even though the universe itself is growing. Galaxies that are currently visible in our telescopes will one day fade from view, slipping beyond the cosmic event horizon. It's as if the universe is pulling the curtain closed on the grand cosmic stage, one galaxy at a time. And this brings us to a truly mind-bending question. What happens at the edge of this expanding universe? Does space itself simply stop? Does it lead to something else? Or is it a boundary we can never cross, no matter how advanced our technology becomes? The truth is, we don't know. But one thing is certain. The accelerating expansion, driven by dark energy, is reshaping the universe in ways we're only beginning to understand. Some scientists speculate that if this acceleration continues unchecked, it could lead to a scenario known as the Big Rip. In this scenario, the expansion of space would eventually become so extreme that it would tear apart galaxies, stars, planets, and even atoms. Imagine the very fabric of reality unraveling at the seams. It's a terrifying yet fascinating possibility that underscores just how much we still have to learn. But there's another side to this story. While some theories suggest that the universe might expand forever, others propose that it could eventually slow down and reverse, leading to a big crunch where everything collapses back into a singularity. And then there's the idea of a cyclic universe, where the cosmos goes through infinite cycles of expansion and contraction. Each of these scenarios paints a radically different picture of the universe's ultimate fate. So, where does this leave us? The expanding universe isn't just a scientific curiosity. It's a window into the deepest questions about our existence. Why is the universe accelerating? What is dark energy? And what lies beyond the horizon of our understanding? Each new discovery brings us closer to answering these questions, but it also reminds us of how much we still don't know. The universe is growing, but our ability to observe it is shrinking. It's a paradox that challenges our understanding of space, time, and reality itself. And as we peer deeper into the cosmos, we're not just looking at distant galaxies, we're glimpsing the boundaries of human knowledge and imagination. And that's what makes the expanding universe one of the most compelling mysteries of our time. What's at the edge? Theories that will blow your mind. Now comes the part that will stretch your imagination. What could actually be at the edge of the universe? Is it a wall, a void, or something we haven't even dreamed of yet? Scientists have proposed some fascinating theories that could completely change how we understand reality. Let's start with one of the simplest and most mind-bending ideas. The universe is infinite. No edges, no boundaries, just an endless expanse of galaxies, stars, and dark voids stretching forever in every direction. This might sound straightforward, but an infinite universe comes with its own set of bizarre implications. For instance, in an infinite cosmos, every possible configuration of matter could exist somewhere out there. That means there could be another version of you, sitting in another version of Earth, watching another version of this video right now. Mind-blowing, right? But what if the universe isn't infinite? What if it's finite, but unbounded? Picture the surface of a sphere, like the Earth. If you keep traveling in a straight line, you'll eventually end up back where you started. This is the idea of a curved universe. Space itself wraps around in such a way that it doesn't have an edge, but it also doesn't go on forever. In this model, you could theoretically journey across the entire universe and return to your starting point without ever encountering a wall or a boundary. Scientists have even speculated that the universe might have a shape like a torus, a giant, three-dimensional donut where space loops back on itself in every direction. Now, let's take things up a notch. What if our universe isn't the only one? The idea of a multiverse suggests that our universe is just one of countless others, like bubbles floating in an infinite cosmic ocean. Each of these bubbles could have its own set of physical laws and constants, making them wildly different from our own. In one universe, gravity might be stronger, and in another, stars might never form. Some bubbles might even pop into existence and disappear in an instant. It gets even crazier at that point. These universes may not only be floating alongside of ours, but actually could be connected. Imagine a foam of soap bubbles in which some of the bubbles merge or interact at their boundaries. If the multiverse is real, then the edge of our universe might not be a barrier, but a gateway to a different realm altogether. There are some physicists who speculate and theorize that black holes may act as doors or gates that can lead to completely different universes from our own. Here, it is hypothesized that every single black hole that exists in our universe may be the source or seed of a completely new universe that lies on the other side of its mysterious event horizon. But it doesn't stop there. The holographic principle suggests that everything we see in our universe, every star, every galaxy, even space and time itself, might actually be encoded on a two-dimensional surface at the edge of the universe. Imagine a hologram where all the information about a 3D image is stored on a flat sheet. If this theory is correct, the universe as we experience it could be a projection from this mysterious boundary. What's beyond that surface? That's a question that might take centuries to answer. And then there's the idea of cosmic inflation. After the Big Bang, the universe expanded at an unimaginable speed, creating the vast expanse we see today. But inflation might not have stopped everywhere. Some theories suggest that inflation continues in other regions, constantly creating new pocket universes. Our universe would just be one pocket in this endlessly inflating multiverse. Finally, let's talk about something truly eerie. What if the edge of the universe is nothingness? Not empty space, but the complete absence of anything. No matter, no energy, not even the laws of physics. This could mean that our universe is surrounded by a void so absolute that it defies comprehension. Some physicists believe this nothingness might be the natural state of existence, with universes like ours popping in and out of it over time. Each of these theories opens up more questions than answers. Is the universe infinite or finite? Does it loop back on itself, or does it end in a void? Could we someday travel to another universe, or are we forever confined to our own? The answers may lie far beyond our current understanding, but one thing is certain: the edge of the universe is not just a place. It's an idea that challenges everything we know about reality. Dark energy and the mysterious force pushing the boundaries. Dark energy is one of the most puzzling discoveries in the history of cosmology. Scientists estimate that it makes up a staggering 68% of the universe, far outweighing the combined mass of all stars, planets, and galaxies. But what exactly is it? That's the thing. Nobody knows for sure. This mysterious force was discovered almost by accident when astronomers observed something that defied all expectations. In the late 1990s, scientists noticed that galaxies weren't just moving away from each other due to the Big Bang, they were accelerating. This was a shock because, according to our understanding of gravity, the expansion of the universe should be slowing down. After all, gravity pulls things together, so why was space speeding apart? Something had to be counteracting gravity on a massive scale, and that something was eventually named dark energy. Now, here's where things get even stranger. Dark energy isn't like regular energy. It doesn't glow, it doesn't emit radiation, and we can't see or measure it directly. Instead, scientists infer its existence by observing its effects on the universe. It's like trying to figure out the presence of wind by watching leaves move. You can't see the wind, but you know it's there. The leading theory is that dark energy is tied to something called the cosmological constant, a term Albert Einstein once introduced and later abandoned, thinking it was a mistake. But now it's making a comeback as scientists believe it could represent the energy of empty space itself. Yes, empty space. The idea is that even the most desolate void in the universe is not truly empty, but filled with this strange, repulsive force that pushes galaxies apart. But that's not the only theory. Some researchers think dark energy might be a dynamic, evolving field, something more akin to a fifth force of nature that changes over time. This opens up wild possibilities. Could dark energy one day disappear, reversing the universe's expansion and causing a catastrophic collapse? Or could it continue accelerating expansion indefinitely, tearing galaxies, stars, and even atoms apart in what scientists call the Big Rip? And here's the big question. What does dark energy mean for the edges of the universe? If it's everywhere, does it extend beyond the observable universe? Could it be the force that defines what lies beyond our cosmic horizon? Some speculate that dark energy might be the link between universes in a multiverse, acting as the glue that holds these separate realms together. Understanding dark energy isn't just about solving one cosmic mystery. It could redefine how we think about space, time, and reality itself. The deeper we dive into this enigma, the more we realize how much of the universe remains a mystery. It's not just a force, it's the ultimate question mark, driving our curiosity to unravel the unknown. If dark energy continues its relentless push, driving galaxies further and further apart, it could lead to one of the most dramatic and terrifying fates for the universe, a scenario scientists call the Big Rip. To understand this, you need to grasp what dark energy is doing. Imagine space itself as an elastic fabric, constantly stretching. Dark energy is like an invisible force pulling at that fabric, accelerating the expansion of the universe. At first, this expansion seems harmless. Galaxies move further apart, making the night sky a bit emptier over billions of years. But dark energy doesn't stop there. It grows stronger as space expands, pulling harder and harder. If this trend continues unchecked, there could come a point where the very fabric of space becomes unstable. In this apocalyptic future, galaxies would no longer just drift apart, they would be ripped from each other. Stars within galaxies, bound by gravity, would lose their hold on one another and scatter into isolation. But it doesn't stop there. Planets would be torn from their orbits around stars, and even moons would drift away from planets. As dark energy grows even more powerful, it targets smaller scales. Eventually, the force of expansion would overwhelm the bonds holding atoms together. Electrons would be flung away from their nuclei, molecules would disintegrate, and the very particles that make up matter could be shredded. This ultimate cosmic disassembly, the Big Rip, would leave nothing behind but an empty, ever-expanding void. No galaxies, no stars, no planets, no atoms, just a dark, cold expanse where even the concept of space and time might cease to exist. What makes this theory so chilling is how final it feels. Unlike the Big Bang, which created everything, or the Big Crunch, which theorizes a cyclical rebirth of the universe, the Big Rip seems to leave no room for recovery. It's the ultimate endgame, the unraveling of reality itself. But here's the real kicker. The timeline for the Big Rip is uncertain. Some models suggest it could happen in tens of billions of years. Others propose it might never happen if dark energy behaves differently than we currently predict. And here's the most tantalizing question of all. What lies beyond the Big Rip? Is it the end of everything? Or could the shredded remains of our universe seed the birth of something new? Could there be other universes beyond, waiting to absorb the energy left behind? These are the questions that keep scientists awake at night, and they're what makes the study of dark energy one of the most exciting and unsettling fields in modern physics. The Big Rip isn't just a theory about the end, it's a window into the unknown. And as long as dark energy remains a mystery, the possibilities, both terrifying and awe-inspiring, are endless. If this doesn't make you want to dive deeper into the cosmos and uncover its secrets, I don't know what will. The cosmic microwave background, our farthest look back. The cosmic microwave background, or CMB, is often called the afterglow of the Big Bang. It's the faintest, most ancient light we can detect, like a whisper from the universe's infancy. To truly grasp its significance, imagine this. About 380,000 years after the Big Bang, the universe was a dense, scorching soup of particles. At that time, light couldn't travel freely because it was constantly colliding with charged particles, like electrons and protons. It was chaos, a blinding fog of energy and matter. But then something extraordinary happened. As the universe expanded, it cooled down just enough for those charged particles to combine into neutral atoms. This monumental event, known as recombination, allowed light to break free for the first time. That light, the cosmic microwave background, has been traveling across the universe ever since, carrying with it an imprint of the universe as it was nearly 14 billion years ago. Think of it like a baby photo of the cosmos. When we observe the CMB, we're essentially looking back in time to when the universe was just a tiny fraction of its current age. It's like opening a cosmic history book, with each page revealing a new layer of the universe's formation. Scientists have spent decades mapping this faint radiation, and every discovery has added pieces to the puzzle of how everything we see today came to be. But here's the fascinating and slightly eerie part. The CMB is a boundary, a cosmic wall we can't see past. It's the farthest back in time our telescopes can look, no matter how advanced they are. Why? Because before recombination, the universe was opaque. The light we see in the CMB was trapped in that chaotic fog, unable to travel freely. What lies beyond that fog is one of the greatest mysteries in modern science. Could there be clues about the very first moments of the Big Bang hiding just beyond the CMB? Or could it reveal a phase of the universe we've never even considered? Some scientists speculate that before the CMB, the universe might have experienced rapid inflation, a period where it expanded faster than the speed of light. If true, that would mean the CMB is like the edge of a stage curtain, hiding the chaotic, explosive act that came before. What's even more mind-blowing is the possibility that the universe might not look the same past the CMB. Beyond this cosmic fog could lie an entirely different reality, one governed by forces and rules we can't even imagine. Some researchers believe that hidden in the slight fluctuations of the CMB's glow are hints of what lies beyond. These tiny variations in temperature and density might hold the keys to understanding the universe's earliest moments, and perhaps even clues about other universes. So, is the CMB the ultimate limit? Not necessarily. Scientists are developing new ways to study what came before it. Gravitational waves, ripples in the fabric of space-time, could provide a way to peer into the universe's pre-CMB era. If we can detect these ancient waves, we might finally uncover what the universe looked like in its first fleeting moments. The cosmic microwave background isn't just a relic of the past, it's a challenge, a tantalizing clue that there's so much more waiting to be discovered. And as we push the boundaries of what we can observe, one thing is certain. The secrets hidden beyond the CMB could change everything we know about the universe and our place in it. Gravitational waves, ripples in space-time. Gravitational waves are one of the most fascinating phenomena in the universe. They're like ripples on the surface of a pond, but instead of water, these waves ripple through the very fabric of space-time itself. These waves are created by some of the most intense and violent events in the universe, colliding black holes, merging neutron stars, or even the birth of the universe itself. But what exactly are gravitational waves, and why should we care? Gravitational waves are a prediction of Albert Einstein's general theory of relativity, which described how massive objects like stars and planets warp the fabric of space-time around them. When two massive objects, such as black holes, spiral towards each other and merge, they create a disturbance, ripples in space-time. that travel outward at the speed of light. Just like a stone thrown into a pond causes ripples to spread out, these gravitational waves spread through space-time, carrying information about their violent origins. For decades, these waves were theoretical, predicted by Einstein, but never directly observed. That all changed in 2015, when scientists at the Laser Interferometer Gravitational Wave Observatory (LIGO) made the groundbreaking detection of gravitational waves from a pair of black holes colliding over 1 billion light-years away. This was a historic moment for science, confirming one of Einstein's predictions and opening up an entirely new way of observing the universe. But what's even more exciting is that gravitational waves have the potential to tell us more than we've ever imagined. Unlike light or other forms of electromagnetic radiation, gravitational waves can pass through almost anything without being blocked or absorbed. This means they can carry information from parts of the universe that light simply cannot reach. They offer us a completely new perspective on the cosmos, one that is free from the limitations imposed by dust, gas, or even the expansion of the universe itself. Now, here's the mind-blowing part. Could gravitational waves be carrying information from beyond the observable universe? This is a question that has been keeping some of the brightest minds in science awake at night. The observable universe, as we discussed earlier, is limited by the speed of light. Only the light that has had enough time to travel to us since the Big Bang can be detected. Anything beyond that lies out of our reach. But gravitational waves travel at the speed of light, and they don't get blocked or absorbed in the same way that light does. So, what if we could detect gravitational waves from beyond the cosmic horizon, the point where light can no longer reach us? Could these waves carry messages from regions of space that we're not yet able to observe with conventional instruments? Some scientists speculate that gravitational waves could be the key to unlocking mysteries that are currently beyond our grasp. These waves could potentially provide us with a glimpse of the universe's hidden regions that are beyond our current observational capabilities. Imagine being able to detect gravitational waves from a black hole merger so far away that it existed before the birth of the observable universe. Or, what if these waves came from a part of the universe that's already gone beyond the reach of light, where the laws of physics are radically different? In fact, some cutting-edge theories suggest that gravitational waves could be our first clue to understanding the true structure of the universe. For instance, they could help us determine if the universe is finite or infinite. If we could detect gravitational waves that have traveled across the entire universe, we might be able to map the universe's shape, its boundaries, or lack thereof, and even its future evolution. Gravitational waves might not just be telling us about what happened when black holes collide. They could also be telling us about the very fabric and fate of the cosmos. But that's not all. Gravitational waves could also be the key to understanding one of the universe's greatest mysteries: the mysterious force known as dark energy. Dark energy is believed to be driving the accelerated expansion of the universe, and scientists have long struggled to understand its nature. If gravitational waves are able to pass through regions influenced by dark energy, they might be able to provide insights into how dark energy affects space-time itself. Could these waves help us unlock the secrets of dark energy and its role in the future of the universe? And then there's the ultimate question: what if gravitational waves could help us peer beyond the very edge of the universe? The concept of an edge of the universe is something that challenges our understanding of space-time itself. While some scientists believe the universe is infinite, others suggest that it's a closed loop, like a sphere with no true edges. Gravitational waves might be able to reveal clues about this structure. They could be the cosmic messenger that shows us if the universe truly has an edge, or if it's part of something much bigger. Perhaps an endless sea of universes, each with its own set of physical laws. Imagine this: each time a gravitational wave is detected, it might not just be carrying information about the event that caused it. It could also be giving us a snapshot of the universe's deepest secrets. As gravitational wave detection technology improves, we could start to detect more distant and more elusive signals. Each of these signals could hold a piece of the puzzle of the universe's edge, or lack thereof. We've only scratched the surface of what gravitational waves can reveal. With the next generation of detectors, like the LISA, Laser Interferometer Space Antenna, mission set to launch in the coming years, we'll be able to detect gravitational waves from even farther and fainter sources. The more we learn about these waves, the closer we get to understanding not just black holes and neutron stars, but the true nature of space, time, and the universe itself. In short, gravitational waves are not just a new way to observe cosmic events. They might be our ticket to understanding the deepest, most fundamental mysteries of the universe. As we push the boundaries of what's possible in gravitational wave astronomy, we're opening up new frontiers that could forever change our view of the cosmos. Could these ripples in space-time hold the key to understanding what lies beyond the observable universe? Only time will tell. But one thing's for sure, the more we discover, the more we realize that the universe is far stranger, more complex, and more mind-bending than we ever imagined. The holographic principle. Is the universe a 3D projection? One of the most mind-bending ideas to have emerged from the fields of physics and cosmology in recent years is something called the holographic principle. It might sound like science fiction, but stick with me, because this theory could completely change the way we think about reality itself. At its core, the holographic principle suggests that the entire 3D universe we perceive, everything from galaxies, stars, planets, to our very existence, might not be real in the way we think. Instead, this theory proposes that the universe is a projection, similar to a hologram, created by information encoded on a distant 2D surface. Yes, you heard that right. Everything we experience in 3 dimensions could, in fact, be a sophisticated illusion, a projection of information stored on a 2-dimensional plane. Let's break it down. In physics, dimensions are the basic directions in which we can move or measure space. We live in a 3-dimensional world, length, width, and height. But what if all this 3D reality is simply a shadow, a projection from the information contained on a 2-dimensional surface? It's like the way a 3D object can cast a 2D shadow on a wall. In the case of our universe, that shadow is everything we know and experience. It's as if the laws of physics we observe, the forces that govern space, time, and matter, are simply the result of a much deeper, more fundamental structure, one that exists on a 2D surface. This idea emerged from a strange and mind-blowing connection between black holes and quantum mechanics. In the 1970s, renowned physicist Stephen Hawking uncovered that black holes emit radiation, which led to the discovery of the information paradox. The question arose, if black holes swallow everything, including light, where does the information about the matter that falls into them go? Does it simply disappear, or is it encoded somewhere else? Enter the holographic principle. One of the key proponents of this theory is physicist Juan Maldacena, who proposed that all of the information inside a black hole could be contained on its boundary, on the surface rather than its interior. In essence, this theory extended to the entire universe, suggesting that the information we experience in 3D could actually be encoded in a much smaller, lower-dimensional space. Imagine every single bit of information about our universe being stored on a 2D surface, like a giant cosmic DVD or a holographic disc. The universe then projects this information into 3 dimensions for us to experience. But what does all this mean for our perception of the universe? And more importantly, what could it tell us about the edge of the universe? If the universe itself is a projection, then the edge we think we perceive might not be an actual boundary at all. Instead, the edge could simply be the limit of how we experience the universe within our 3D perceptions. This could be a crucial point in understanding the universe's true nature, one that may be fundamentally different from the way we experience it. This theory raises all kinds of incredible possibilities. What if the universe's edge is simply a boundary between dimensions, where the familiar laws of physics as we know them break down? Instead of a physical edge where everything stops, the boundary could represent the limits of our comprehension of space and time. The laws of physics that govern our reality might not hold up when you step outside the holographic projection. Could it be that at the edge we encounter entirely new dimensions of existence? What if our reality is only one of many, with different rules that we can't yet understand? The holographic principle opens up the possibility that we might be living in a simulation-like reality, one that is far more complex and multi-layered than we could have ever imagined. And the implications of this are staggering. If this theory is true, it suggests that our entire universe, everything we've ever known, might be a construct based on a far deeper, far more complex reality. The concept of the universe as a hologram challenges our fundamental beliefs about the nature of existence. It pushes us to consider the possibility that what we see and feel every day, the space between us, the stars in the sky, the atoms that make up our bodies, might not be as real as we think. Instead, they could just be projections of information encoded on some distant, unseen 2D surface, one that we are unable to directly perceive with our senses. To make this even more mind-bending, consider this. What if the universe, this seemingly infinite space we observe, is just one layer of a much larger cosmic structure? If we're living in a holographic universe, could it be that other dimensions exist beyond our perception? Dimensions that are hidden from us because they exist outside of the 3D projections we experience? The edge of the universe might not be a final destination, but instead a place where the laws of physics break down, where we could encounter entirely new realms of existence. This idea, while still a theory, forces us to rethink everything we've ever learned about space and time. If the holographic principle holds true, it might not just explain the nature of the universe, but it could open the door to new ways of understanding reality itself. It asks us to think beyond the familiar and embrace the possibility that the universe might be far stranger, more intricate, and more beautiful than we could ever imagine. So, if the universe is truly a holographic projection, then everything we thought we knew about its structure, its boundaries, its edge, and its ultimate fate could be completely wrong. What we think of as the edge of the universe might simply be a projection, a place where we encounter limits in our understanding, but not a final boundary. It could be the first clue to something much deeper, something beyond our ability to perceive or comprehend. And that is exactly why scientists are so intrigued by the holographic principle, because it suggests that the universe is far from what we think it is. And perhaps, just perhaps, we're only scratching the surface of what's really out there. The role of quantum entanglement. Could it hold the key to understanding the edge? When we talk about the universe and its mysterious edge, one of the most intriguing and perplexing phenomena that could help us unravel the truth is quantum entanglement. Now, you might be wondering, what does something as bizarre and fundamental as quantum mechanics have to do with the edge of the universe? The answer is more profound than you might think. Quantum entanglement is a phenomenon that has baffled physicists for decades. It's a curious connection between particles, so strange in fact that Albert Einstein famously called it spooky action at a distance. Here's how it works. When two particles become entangled, their states are instantly connected, no matter how far apart they are. Whether they're on opposite sides of the universe or just a few centimeters away, the behavior of one particle directly influences the behavior of the other, without any observable time delay. It's as if the particles are somehow communicating faster than the speed of light. But how does this quantum weirdness tie into the mysteries of the universe's edge? Well, as it turns out, quantum entanglement may hold the key to unlocking some of the most perplexing aspects of space, time, and the ultimate structure of reality. Let's explore how. At first glance, quantum entanglement seems to defy our understanding of space-time. The connection between entangled particles is not bound by the limitations of distance or time that we experience in our everyday lives. In classical physics, information can't travel faster than the speed of light, but quantum entanglement challenges this idea. It suggests that there's a deeper layer of reality, one that operates on a level beyond the confines of traditional space-time. This leads us to an intriguing possibility. Could the entanglement of quantum particles offer a glimpse into what happens at the edge of the universe? Some physicists argue that quantum entanglement may play a role in connecting distant regions of space-time, even ones beyond the observable universe. If entanglement is a fundamental property of the universe, then it could be the mechanism that links different parts of the cosmos, regardless of the vast distances between them. Now, let's bring this idea back to the concept of the edge of the universe. We know that the observable universe is limited by the distance light has traveled since the Big Bang, roughly 93 billion light-years. But what happens beyond that limit? What if the edge of the universe isn't a hard boundary, but a region where the rules of classical physics start to break down? This is where quantum entanglement comes into play. Some theories suggest that quantum entanglement could allow information to transcend the observable universe, bridging the gap between distant parts of space-time. Picture this. The universe is like a vast, interconnected web, where each point is linked by entangled particles. Even though we can only see part of this web, quantum entanglement could be the invisible thread that connects distant regions of space. In this sense, the edge might not be a physical barrier, but rather a point where our understanding of space and time begins to change, where the limits of what we can observe give way to a deeper, more interconnected reality. But there's more. In recent years, some scientists have proposed that quantum entanglement could even be linked to the very fabric of space-time itself. According to some models of quantum gravity, space-time may not be a continuous smooth fabric, as we traditionally think of it. Instead, it could be made up of discrete, quantum units, like pixels on a screen. In this scenario, quantum entanglement could be the force that holds these units together, creating the illusion of a continuous universe. If this is true, then the edge of the universe might not be a physical location at all, but a point where our current understanding of quantum mechanics and general relativity meet, and potentially where the very structure of space-time itself breaks down. In this model, quantum entanglement could be the key to understanding how the universe functions at its most fundamental level, offering clues about what lies beyond the edge of our observable reality. What if the edge of the universe is the point at which entangled particles can no longer communicate across the vast distances of space-time? Could the limits of the observable universe mark a threshold beyond which the laws of physics, as we know them, no longer apply? If quantum entanglement is indeed the bridge that connects distant regions of space, then the edge could represent the point at which that connection starts to fade, where entanglement itself reaches its limit. This idea also ties into some of the most mind-boggling theories in physics, such as the holographic principle and the concept of a multiverse. The holographic principle suggests that our three-dimensional universe is actually a projection from a two-dimensional surface. If quantum entanglement plays a role in this projection, it could mean that the edge of our universe is merely a boundary between different layers of reality, possibly marking the transition from one universe to another, or from one dimension to another. This boundary could represent the limit of our perception, beyond which new physical laws govern the cosmos. Additionally, some researchers believe that black holes may play a pivotal role in understanding quantum entanglement and its relationship to the universe's edge. Black holes are regions of space where gravity is so strong that not even light can escape. However, quantum mechanics tells us that black holes cannot simply erase information, they must encode it somehow. This is known as the information paradox. Some scientists propose that quantum entanglement could be the mechanism through which information is preserved inside black holes and transmitted across the universe. If this is true, black holes could provide us with a glimpse into the structure of space-time beyond the observable universe, and quantum entanglement could be the link that allows information to travel beyond the edge of the universe. To sum it up, quantum entanglement offers a glimpse into a much deeper, interconnected reality, one that challenges our understanding of space, time, and the very nature of the universe. As we continue to explore the possibilities of entanglement and its connection to the edge of the universe, we may be on the cusp of unlocking some of the most profound mysteries of existence itself. The edge of the universe might not be a physical boundary at all, but a place where the entangled fabric of space-time begins to unravel, revealing a whole new realm of possibilities. The more we explore quantum entanglement, the more we realize that the universe is far stranger and more interconnected than we could have ever imagined. Now we reach the most jaw-dropping part of this journey, the moment where things get mind-bending. Recent studies suggest that the universe may not just expand forever. It might do something even stranger. It could fold back on itself, creating a loop that defies all of our conventional understanding. Think of this like a Mobius strip, a surface with only one side. A surface that, when you trace along it, takes you back to the very starting point, without ever reaching an edge. If the universe behaves like this, what we see as the edge of the cosmos could actually be a beginning point, bringing us full circle back to where we started. But wait, it gets even stranger. We're not just talking about a loop within our own universe. What if our universe is just one part of a much larger cosmic landscape? The multiverse. Imagine a reality where our universe is merely a bubble in a vast eternal sea of other universes. Each of these bubbles could have its own set of physical laws, dimensions, and even entirely different versions of reality. The edge of our universe might not even be the end. It could be the very beginning of another universe, a whole new realm of existence with laws we can't even comprehend. Think about it. What if every black hole in our universe isn't just a point of infinite density, but actually a doorway to another universe entirely? Some theories suggest that black holes could serve as portals, connecting different universes in this infinite cosmic web. Picture this. Our universe is just one node in an enormous cosmic network, where each node is connected by mysterious bridges of space-time, and each black hole is a doorway leading to another parallel universe. What lies at the edge of our universe could be an entrance to something entirely new, a fresh reality waiting to be explored. And here's the kicker. If this is true, the edge of the universe is not a static boundary at all. It's a moving, shifting, and evolving point. As we learn more, we find that the universe isn't just expanding outward in the conventional sense. It's creating new universes, each with its own expansion, starting from its own cosmic edge, and this process could go on infinitely. Some scientists propose that our universe itself was birthed from the collapse of a previous universe. A cycle of birth and rebirth stretching beyond the boundaries of time itself. Could the edge of our universe be the result of this cosmic recycling, a threshold where new realities emerge? But even this theory of the multiverse might not be enough to explain everything. Some researchers speculate that we might exist in a simulation, yes, a computer-generated reality. According to this theory, the edge of the universe might not even be real, but just a construct within a larger, artificial framework. Our entire existence could be part of a grand simulation, and the edge is just a boundary created by the simulation's architecture. If this is true, the nature of reality itself is far more complex than we could ever imagine. And then there's the concept of the holographic principle. What if everything we perceive as the universe, space, time, and even our very existence, are just projections? According to the holographic principle, the universe might actually be a 2D surface, and the 3D space we live in is nothing but a projection from that surface. The edge of our universe could be the boundary where the projection fails, revealing a deeper, more complex reality beyond what we can comprehend. Imagine standing at the edge of a hologram, watching it flicker and unravel, and realizing that the real world exists beyond the boundaries of what we see. This theory could completely change our understanding of the universe and reality itself. Now, let's take a step back and think about the cosmic scale. If the universe is truly infinite, then what does that mean for the edge? We've been conditioned to think that the universe has a beginning, an end, and some kind of boundary. But what if that's just an illusion? What if our universe stretches out forever, with no true edge at all? We could be trapped in a cosmic loop that's impossible for us to fully grasp. Some physicists believe that the idea of an edge might simply be a human construct, one we've built around our limited understanding of space and time. The very notion of boundaries may not even apply to the universe on a grand scale, and our perceptions of space could be drastically wrong. This raises the question, what happens when the expansion of the universe reaches its limit, or if there even is a limit? One theory known as the Big Rip suggests that dark energy, the mysterious force accelerating the expansion of the universe, could eventually tear everything apart. Galaxies, stars, planets, and even atoms could be ripped apart by the relentless expansion of space. If this happens, could the edge of the universe be the point at which this ultimate destruction begins? Or could the Big Rip mark a new beginning, as a new universe forms from the remnants of the old one? With all these theories and possibilities, one thing is for certain: the edge of the universe is not something we can simply observe or understand. It's an idea that stretches the limits of our imagination, inviting us to question everything we think we know about reality. Whether it's a boundary between universes, a point of infinite expansion, or a projection in a simulated world, the true nature of the universe's edge might be far stranger and more elusive than we could have ever imagined. So, what does all this mean for us? What's next for humanity as we continue to explore the cosmos? Are we on the brink of discovering new universes, new dimensions, and new laws of physics? Or will the edge of the universe forever remain a mystery, one that tantalizes us with possibilities we'll never fully grasp? Stay tuned, because the journey to uncover the secrets of the universe is just beginning. The edge isn't just out there. It's in here, within each of us, pushing the boundaries of what we know and what we can dream. As we come to the end of our journey to the edge of the universe, we realize that what we've uncovered so far is just a glimpse of the profound mysteries that lie beyond our reach. The edge of the universe is not just a physical boundary. It's a concept that challenges the very fabric of reality as we understand it. We've explored the limits of what we can observe, from the cosmic microwave background to the stretching of galaxies caused by dark energy. But what's truly mind-blowing is the fact that these theories and observations might only be scratching the surface of something far more complex and strange. Let's take a moment to consider just how incredible this journey has been. We started by looking at the observable universe, this enormous bubble where light from distant stars and galaxies has had time to reach us. But even within this bubble, the universe is constantly expanding, its galaxies rushing away from us faster and faster. And as much as we can see, there's an even larger portion of the cosmos that we can't. That's because the speed of light limits how far we can observe. Beyond the cosmic horizon, there could be new galaxies, new phenomena, or even new dimensions that we're completely unaware of. What's out there remains one of the greatest mysteries in science. Then we dove deeper into the nature of the universe's expansion. We learned that not only is the universe expanding, but it's doing so at an accelerating rate. This astonishing discovery is driven by a mysterious force known as dark energy. It's responsible for pushing galaxies farther apart, and it's something that, until recently, we barely understood. In fact, dark energy makes up a whopping 68% of the universe, yet we still have no clear idea of how it works or what its true nature is. Some even suggest that dark energy could lead to the end of the universe in a cataclysmic event known as the Big Rip. In this scenario, the relentless expansion of space could eventually tear apart galaxies, stars, and even atoms. But what happens after that? Could this be the true edge of the universe, or is there something else, something even stranger, waiting to be discovered? We also took a journey into the mind-bending possibilities of the universe's structure. Could the universe be infinite, stretching out forever without end? Or, as some theories suggest, could it be finite, with an edge that we simply can't observe? Some have proposed that the universe might be like the surface of a sphere, where if you travel far enough in one direction, you'd eventually come back to where you started. This idea challenges everything we think we know about space and time. And if the universe isn't infinite, what's beyond its edge? Could there be another universe on the other side? A multiverse, perhaps, where countless other realities exist, each with its own unique laws of physics, dimensions, and possibilities? The notion that our universe might be just one bubble in a vast cosmic sea is both exhilarating and terrifying. It suggests that everything we know, every galaxy, every star, every planet, is just a tiny part of a much grander, much more complex reality. And we can't forget about the role of gravitational waves. These ripples in space-time are caused by some of the most violent events in the universe, like the collision of black holes. Scientists have recently begun detecting these waves, which are providing us with a new way to understand the cosmos. Could gravitational waves hold the key to unlocking the secrets of what lies beyond the observable universe? What if these waves could be used to peer into regions of space we can't directly observe? The potential for discovery is enormous, and it could lead to new insights into the very fabric of the universe. Perhaps the most radical concept we explored was the holographic principle, which proposes that our entire 3D universe might be a projection of information stored on a 2D surface. If this theory is correct, then the edge of the universe might not be a physical boundary at all. It could be a boundary between dimensions, a place where the laws of physics as we know them break down completely. Imagine a universe where space and time as we understand them are merely illusions, and the true nature of reality is something far stranger and more complex. This idea challenges everything we've learned from classical physics and opens the door to a whole new way of thinking about existence. But as we venture deeper into these theories, it becomes clear that the true nature of the universe's edge may not be something we can fully comprehend, not just yet. The edge of the universe is not a simple, tangible line we can cross or observe. It's a concept, a puzzle that stretches our imagination and tests the limits of our understanding. Every theory we've explored today, the possibility of a finite universe, the multiverse, the role of dark energy, adds more layers to this complex question. And every discovery we make leads to more questions, showing us just how little we really know about the cosmos. Now, as we stand on the precipice of these cosmic mysteries, it's clear that the edge of the universe isn't just an academic question. It's a profound philosophical inquiry. It forces us to confront our place in the universe, our understanding of reality, and the very nature of existence itself. How far can our minds stretch? How much can we truly grasp about the infinite expanse of space? And perhaps most importantly, what does it mean to be human in a universe that's so vast, so unfathomable, and so filled with secrets, waiting to be uncovered? So why does this matter? Why should you care about what lies at the edge of the universe? Because this is not just a scientific quest. It's a journey that invites us to ask the most fundamental questions about life, existence, and our place in the cosmos. The answers, though elusive, shape our understanding of everything around us. Whether it's the future of our own planet or the potential for life on other worlds, the edge of the universe touches all aspects of our lives and our future. As we continue to unravel these mysteries, it's clear that we are on the brink of a new era in science. The edge of the universe may not just be a distant, unreachable frontier. It could be the gateway to a new understanding of reality itself. Every new discovery brings us closer to that edge, and every step we take pushes the boundaries of human knowledge further than we ever thought possible. So, if you're fascinated by the unknown and excited by the possibility of new discoveries, hit that subscribe button and join us as we continue to explore the mysteries of the universe. We've only just begun, and there's so much more to uncover. Stay curious, stay intrigued, and let's keep pushing the limits of what we know together. Well, if you enjoyed the video, then hit that subscribe button to explore more cosmic mysteries, or watch this next video to uncover the secrets of how the universe began.